We will look at solving the equation 2 over x squared plus 1 equals e to the x, using a graphical method on a graphic calculator. Firstly, we will look at the Casio model and begin by selecting the graphing module number 5. I've already entered the left-hand side of this equation, and it remains now to enter the right-hand side, which is e to the x. So that done, we need to execute it, and I will use F6 draw. The picture that you see does not make it obvious that there's an intersection at all here, and that therefore there may well be no solution to the equation. However, quite commonly, you start one of these problems with a window that was left over from a previous calculation. So you do have to be careful, and it's often the case that the first window you look at doesn't show any graph at all. But here we can see the graphs, but it's not obvious what's going on. You've got two ways of handling this. You can either use Zoom F2 or View Window F3. If I use Zoom, I will need to zoom out, obviously, that's F4, and pick a center for the zoom out, so that would seem to be roughly the case, that I've chosen the right center of zoom, because we can now see that there actually is an intersection. You do not need to have a very close-up view of these intersection points, but I think it's a good idea to maybe take a closer look. So I'm going to zoom back in now at a point centered around where the intersection appears to be. So I'm using the arrow keys to move that point across to the place I want to center the zoom. And there we have it. We clearly have an intersection point, and therefore at least one solution to this graph. On Casio models, you use GSolv, which stands for Graph Solve. So I will pick GSolv, and the option I want is intersection. And the calculator thinks for a second or two, and it produces the coordinates of the point of the intersection. So we can see here that our solution suggested is 0.483259 and so on. Are there any other intersection points? You will recall that what was going on down the left was not massively obvious. So having secured at least one solution, we probably need to look and see if there's going to be a solution down to the left for a reasonably large negative. So I'm going to zoom out again. I might zoom out at a place which is looking like it might be a bit closer to the point of interest. No intersection point seems to be suggesting itself, so we might zoom again, zoom out again, and this time we'll point the cursor more closely in the area we're looking for. Now, I've zoomed out too much, so what we probably need to do now is have a look at this area here way over to the left to see if the red and the blue graph cross each other and produce a new solution. So I will pick this time zoom box. Now, box allows you to put a box around the part of the graph that you want to look at more closely. So I've moved my cross pointer over to the left, execute to fix the bottom left corner of the box, and I'll use the arrow keys now to open up a box that will show me what's going on here. Well, it does appear that the red graph stays way below well, not way below, but below the blue graph, and that we have one solution to this problem and one solution only. If you're not satisfied with what I've done here, all you've got to do is look at further and further over to the left just to see whether there is a solution. But the calculator will also help you, because you can actually use GSolve again, look for intersection, and we haven't found a second intersection, and so I think we're done. Solving the same problem on a TI graphic calculator, you need to open the right type of document, so I will choose Open New Document, and we want to solve this graphically, so this is document type number 2, Add Graphs. The first thing we have to do is enter the two parts of the equation we're trying to solve. So the left-hand side is 2 divided by x squared plus 1. You need to be a bit careful here to make sure that the plus 1 does not go in the index. If you're using just the squared key, that's all right, but if you use this caret key to get you a power, you will find that the cursor stays in the index and you need to use the arrow keys to get it down again. So just make sure that this is exactly what you want and press enter, and you will get a rather nice, very normal notation display of this on the screen. This is what we want, and what we need to do next is we need to enter a new function, which I will do using graph entry edit function. So the second one is e to the x, and enter it, and because I've got a standard window here, we are actually seeing the intersection point straight away. To find the actual coordinates of the intersection point, you choose Analyze Graph. So we want intersection. Texas works by allowing you to set a sort of channel. So you can move this using either the touchpad or the arrow keys, and open this up so that it produces the intersection point that you want. We've only got this to 3 decimal places. You may well want to alter that, and it's in settings. Now you will see that we have got this set to display digits float 3. If you want it at a higher level of accuracy, just select the higher level of accuracy that you want, and the correct answer is immediately reflected in the display. We raised the issue of whether there is a second intersection point down here. Well, you can use the same procedure on the Texas as we did before. You can zoom in on the area or not, but you can also use Analyze Graph a second time, and we'll have a look for an intersection right down here by setting up a new channel down which we're looking, and we've not found one. I can move the whole thing over, and we can look much further down here. So we'll do the whole thing again, Analyze Graph, look for an intersection down at -28, and no intersection is found. So I think we've solved this problem using the Texas Instruments device.